Alright, so welcome back. So this time let's talk about Gaussian elimination. Gaussian elimination is a method used by the great mathematician Gauss to solve system of equation using matrix. So there are several steps that you must follow in order for you to apply the Gaussian elimination to solve system of equation. So the step 1 is we write down the system of equation. The second step, we perform row operation or row equivalence as necessary to transform the matrix so this is our goal. We should be able to create this form. So we keep on applying row equivalence until we reach this form. So look at this. We have sets of 1 in diagonal order, and then we have the triangular form of zeros at the bottom. So this is the goal that we must achieve for Gaussian elimination. Okay, so n here refers to any number, whether it's positive or negative. Okay, so after doing this, step 3 is we write the matrix and then for the last part, use substitution. Okay, so let's review the rules for Gaussian elimination. So we have to write down the system of equation into a matrix. Into a matrix form. Into a matrix form. Then after that, we'll perform row equivalence until we reach this format. So we have zeros at the bottom and then 1 in diagonal form. After reaching this form, we have to transform back the matrix into system of equation. And then we will use substitution to find the values of missing variables. Okay? So I want you to take note of this, pause this video for a while, and then copy these important notes, and then we will do some examples on how to apply these rules. Okay, so let's have some examples of this. I'm going to erase this now. Okay, so let's say we have this system of equation. We have x plus y minus z equals to negative 2. And then we have 2x minus y plus z equals 5. And then we have this negative x plus 2y plus 2z equals to 1. So let's imagine that this is the given system of equation. Now let's try to find out what are the values of y, z, and x. Now using the Gaussian elimination, we can find those missing numbers for x, y, and z. So let's try solving this using Gaussian. So the first step is to transform this into a matrix, augmented matrix. So we'll write here 1, 1, negative 1, and then negative 2. Then we have 2, negative 1, and then z is positive, so let's write, so let's write here positive 1, and then 5. X is negative, so let's write down here negative 1, and then positive 2y, so let's write here 2, and then positive 2c, let's write here 2 again, and then 1. Okay, so this is the way how to transform system of equation into an augmented matrix. The next, after transforming the system of equation into an augmented matrix, remember our goal is to turn this into 0, this one, and this one. So these numbers in circles must be turned to 0. And then we have to maintain a diagonal one here. Okay, so that is our goal. We will apply row equivalence until we turn these numbers in circles to 0. And then these numbers in diagonal to 1. Then after that, that's the time we will find the values for the variables. Okay? So this is 2. This is 2 and then negative 1. Okay, so let's start. Let's apply row equivalence. Let's start dealing with this. Let's try dealing with these numbers, the 2 and the negative 1. What number do you think that when added, multiplied to this number, it will turn these numbers to 0? We have to guess for that number. But on this case, I have already computed this one. So I believe that this row, when this is multiplied by negative 2, and then with the R1, if we will multiply negative 2 with R1, so we will get negative 2, and then add it to row 2, then we will be able to get 0. Okay? So negative 2 times R1, which is 1, so it will give us a result of negative 2. So negative 2 plus positive 2, so this becomes 0. Okay, let's have another row operation here. So what number do you think that when multiplied to this or added to this, it will give us 0? So maybe we can use R1 plus negative 1, it will become 0. So let's write here R1 plus R2. Obviously it will give us 0. I'm sorry, not R2, R3. We are working with R3, so this should be R3. Okay, so let's do this. Let's create another matrix here, applying the row operation for this matrix. We did not touch the topmost row, so we will just copy everything there. Alright, so this time we will work on the second row. Negative 2 times R1, so this becomes negative 2. So this is our negative 2 times R1. R1 is 1, and then plus 2. So this becomes negative 2 plus 2, this becomes 0. So that is why we are going to write here 0. Okay, let's keep on doing that. Let's continue. So this time negative 2 times R1. R1 is positive 1 plus R2. R2 is negative 1. So let's write here negative 1. So negative times positive, this becomes negative. And then unlike sign, so this becomes negative. Okay, so negative 2 minus 1, and that is negative 3. So we have to write here negative 3. So this is negative 3. Okay. Okay, let's continue. So negative 2 times R1, that is negative 1, plus R2. R2 is 1. Okay. So negative times negative, that is positive. So let's write here positive 2 plus 1. Then this becomes 3. So let's write down here 3. Okay. And then negative 2 times R1. R1 is negative 2 plus R2. R2 is 5. And then negative times negative, that is positive, plus 5. So we have 9. So let's write here 9. Okay. And then let's work for the last row. R1. R1 is 1 plus negative 1. This becomes 0. R1 is 1 plus 2. This becomes 3. R1, negative 1 plus 2. That is positive 1. And then negative plus positive, this is negative 1. Okay, so this is now the result after applying this row operation. So this row operation results to this row. This row operation results to this row. So whatever we did on this matrix, it does not change the equality of this matrix to this matrix. Okay, that is why it is called row equivalence, because everything, even they differ from how they look, but they are still equal because what we did are all valid legal operation from row equivalence. Alright, so let's continue. So now let's work on these numbers. So we have to turn this to 1 and to turn this to 0. So again, we have to think for a number. Think for a number that when you multiply it or add it to this number, it will turn this to 1. And for this number, it should turn this to 0. Okay? So let's try 1/3. Okay? So let's try here. Negative 1/3 times R2. So we can use negative 1/3 multiplied to negative 3, it will give us positive 1. So let's say we have negative 1/3 times negative 3. Negative 3 divide 3. So we have negative 1. Negative 1 divide negative 1, positive 1. Or we can look it in this way. Negative 1 times negative 3, this becomes positive 3. And then 3 times 3, positive, this will also give us positive. And then 3 divide 3 will give us 1. So meaning we can make use of negative 1/3 times R2 to change this into 1. Okay? And then maybe we can also use the same thing for this. We can write here, we can add R2 to R3, because adding -3 to +3 will give us 0. So we can write here R2 plus R3. Okay. So let's work on this. Let's write here the continuation. So -1/3 times R2. So this is 0. Any number multiplied by 0, it will always be 0. But before that, we have to copy first everything from the top. 1, 1, -1, and then -2. And then from here we have 0. And then this becomes 1. And then this becomes -1. Okay? And then this becomes -3. So why -3? Because 1/3 of 9 is 3. Since we have a negative sign here, negative times positive, that is negative. So that is why we have -3. And then for the last row, R2 is 0 plus R3 is 0. The result is still 0. -3 plus +3, that is 0. And then -1, I'm sorry, we are right here. +3 plus R2, remember R2, so R2 is +3 and R3 is +1. So let's add this, we will have 4. R2, 9 plus -1, this becomes 8. Okay, so there you go. So we have one last number to go. If we can turn this to 1, then we are done. Okay, so let's continue. What number can we use for this so that we'll be able to turn this to 1? So we can multiply, I guess, by 1/4. Okay, positive 1/4. This part here is 1/4 times R3. Okay, so let's give this a try. So we did not touch the row 1 and row 2, so meaning we are just going to copy everything there. 1, 1, -1, and then -2, and then 0, 0, -1, then -3, and then 0 times, remember we have 1/4 here, 1/4 times R3, that is 0, so still the result is 0. 1/4 times R3, still 0, so we have 0 here. 1/4 times 4, so this becomes 1. How? So we have 1/4 times 4/1. So let's multiply this, we get 4. And then let's multiply this, we get 4. Let's simplify this, we get 1. So therefore we have 1 here. And then 1/4 of 8 is what? What is the 1/4 of 8? That is 2. Okay? So now, let's review our matrix. I'm sorry. We copied this number incorrectly on this part. So remember, we did not touch row number 2. What should happen is that we are just going to copy everything from the top where there is no row operation. So 1, 1, -1. These are the numbers here. -2. 0, 1, -1. 0, 1, -1. Okay, so there you go. So at this point, we were able to create this triangular 0 and the diagonal 1. So meaning, we are done with the Gaussian elimination. Let's now find the values for our x, y, and z. Okay? For now, I'm going to erase this first so that we'll have enough space to use to continue solving the problem. Okay, so let's rewrite this. So we have now these numbers 1, 1, negative 1, and then we have the negative 2, and then we have 0, 1, negative 1, and then we have negative 3, and then 0, 0, 1, and then positive 2. Okay, remember, this column are the values for x, and this column are the values for y, and this column are the values for z. Okay, so for z, we already know that z is equals to 2. We can now make use of c to solve for y. Okay, so we have now the value for z. Let's try solving for y. To solve for y, you have to write here y solving for y. Solving y. So we have to write here y minus z equals negative 3. Okay, and then we can substitute the value of z, which is 2. So let's write this 2, and then is 3. Okay, we can perform elimination here. Y becomes equals to negative 3 plus 2. So y is negative. So y is negative 1. So we know that y is now negative 1. Alright, so this is now our final answer for y. Let's now solve for x. So x is 1, so let's write down here x, positive y, and then negative z equals negative 2. So we know that the value for y is negative 1, so let's write this to negative 1, and then for our z we have negative 2. Let's write here negative 2, and then negative 2. Okay, so x, so positive, negative, this becomes negative 1, and then negative 2 equals to negative 2. So let's transpose everything. Let's perform elimination. So x becomes negative 2 plus 1 plus 2. So x is negative 2 plus 1, that is negative 1, negative 1 plus 2, that is positive 1. So x is positive 1. So the value for x is 1. So there you go. We were able to solve the system of equation using the Gaussian elimination. Okay, so to perform checking whether we were able to get the correct values for z, y, and x, we can substitute this to these variables. Okay, but for now you can pause the video and copy this everything. Okay, so let's try substituting all the values that we get from Gaussian elimination. So x is 1. So let's write here 1 plus y. Y is negative 1 minus z is 2, and then equals negative 2. So this is 1 plus 1, which is becomes cancelled out because it is 0, and then what is left is negative 2 is equals to negative 2. So this is correct. Let's try for the second equation. 2 and then the value of x is 1 minus y is negative 1, plus z, what is z? Z is 2, and then 5 equals 5. So let's simplify. 2 times 1, this becomes 2. Negative positive, positive 1, plus 2 equals 5. Okay, so if you're going to add this everything, it will result to 5. 2 plus 1, 3. 3 plus 2, 5. So meaning this is correct. For our last equation, we have negative x is 1. So let's write here 1 plus 2y, y is negative 1, plus 2z, z is positive 2, equals 1. So let's simplify this. So negative 1 plus positive negative, so this becomes negative. Because positive 2 multiplied with negative 1, this becomes negative 2. Okay? Plus 2 times 2, this is 4, equals 1. So negative minus negative, so this becomes negative 3 plus 4 equals 1. So negative 3 plus 4, this becomes subtraction, and then we will follow the sign of the highest number. So this becomes 1, and then 1 is equals to 1. So there you go. So we have correct values for z, y, and x. So that's how you perform Gaussian elimination to solve system of equation. Okay, so that's all for this video, and then see you in the next lectures.